will talk about the box-Miller method in order to transform the two independent uniform distribution U1 and U2 into the normal distribution. Okay, so let us start with a few things. So I will use the three libraries, digest, ggplot, and then grid extra in order to, so those tools are for visualization, and this one is for hashing, MD5 to be exact. Okay, so from the last time we know that there's a function, the hashing function in this case, MD5, which can be used to transform the any sequence, any order sequence, like one from 1000 to 100, from 1 to 1000 into random sequence or stochastic sequence, right? And then we know that the ggplot function can be used in order to visualize the histogram for any sequence, right? So let me run this one and then show you the what it does in here. So the first thing is it will give you the function, the histogram, uniform histogram for this these 1 2 3 4 5, so 4 graph, and then I just put them in the same place with the same view with the grid arrange function in this grid extra, right? So and I named them as well. So basically Alice, Bob, Cody, and David. So they are uniform, and then they look like this. You can try any other sequence as well. So for example, if you don't want this MD5 function, you can change into, for example, x equal to n random unit 1000, for example. Actually, you can let us try with 300 500 and then see how. I also run the same thing again. Let me, okay, so, and then you have another sequence like this. So basically they are random numbers in box. And here, because I just give you like 500 samples, so it will look like this. But then if you sample more, it so this one doesn't it doesn't look very uniform, because it's just like 30 bucks or 30 bins in here, and then we have only 500, and then you have to divide. You don't have enough samples to divide into bins. So if you want more sample, then you just skip 5000, and then you can run the there you go. So you have more. Okay, let me copy this into a new page, and then later we can compare line for line. Okay, so this is what we do for visualization. So this one is just about you can generate any function. Or let me show you another option. So instead of using random uniform, I use random normal, like this. So it's basically, this is the bell curve or the normal distribution. Okay, so meaning that you can try different things in here. And then in this video, I will show you how to replace this normal function with the this unknown function with the our own unknown function with the box Miller. So this is the, if you look into if you Google the function, it look like, so basically if you have two random two uniform distribution u1 and u2 independently, you can blend them all together, and then you can have with this Box-Muller transformation, and then you can have the normal distribution. Okay, now let us start with the writing a new function called norm 5. I add the 5 at the end in order to show that this is the MD5 function. So you can generate anything with MD5. Okay. So I will use the function x here to show that you have the transformation sequence. So you can give any sequence, and I will give the default sequence, which is 1 to 1000, and then I will use this function to transform. I will need u1, then this one will give you x, and then with the path here. So I want to use the defaults as well, so I will give path Alice, and then I will put this default values here into the n5 function. So the second one, you do the same thing. We do the same thing, which is 2 for this one, and then this is the tricky part, because if you use the same padding function here, it will give you the two u1 and u2, which are the same thing, which is like dependent, and then this Box-Muller function doesn't work because it violates the independence assumption of the u1 and u2. So in order to do that, for MD5, the trick is very simple, because you just paste anything with anything like A, B, C, D here, something like this, and then it will become Alice plus A, B, C, D, and then it will become another sequence, and then you just use this one. They will be independent because of the nature of the MD5 function here. Okay, and then you just copy this one. If you want to understand more, you can see the wiki link I paste in here, or you can Google, but then you just paste the function here, x equal to the whole thing like this, and then you return x. So it will give you the Box-Muller transformation of the u1 and u2, and then you have a new function here. I put the division line here for us to make sure that we understand our code with this one, and this one, the 3 functions. Okay, so after this, and then you have 3 function, and then you can use this MD5 function here, the same as before. So x here, MD5 x, and then okay, this one is a little bit tricky, and then I will path anything. I will path, oh, because I have Alice here already, so I just path this function with Alice in here, and then I hope it will go well with Bob and Cody and David as well. Okay, so let us run the thing. Okay, I close this one. We will compare like for like this one later. Okay, so there you go. So this is our Box-Muller function, and it look like this. And if you want the original function okay, so let us see how different this thing can be. I want to compare like for like them, but then I need to remember this picture. So there's a mechanism to draw 2 of them at the same time, but I don't want to make it complicated for now. So I just want to replace this picture with the this picture. Okay, so I just replace the function. This one is the original unknown function, and this is our new function, and then I run the figure. You see here the dot is around this one, and this one is smoother because it has like 5,000 sample, but here we only have like, okay, let us do 500 and see how 500. Okay, so you can see here because you only have 500, and then as a result the bell curve is not quite symmetric, and then you see the count here also 40 something only, so maximum. But if you turn this one on, and then it become the 500 something, right? So it is a big number. Okay, so that's how you change, you fix the you define the function with the box Muller method, and you don't need to define it for you. I wrote another function here. We will just compare line for line the two. So in this case, I also have the same mechanism, but I have here it part 2. So part 1 is the original. Part 2 you can put part 2 in the sequence in the parameter as well. So basically you can generate any sequence you want based on the two, but don't put the same one. For example, this one Alice, and part 2 also Alice, then it doesn't work because the two variables actually are the same, and then the box Muller function doesn't work like that. And then this one is everything else is the same. I think everything else is the same, so it's like this. So that's it, guy. So now you know, if you are like MCMC student, you know how the box Muller works already, and then you can choose any U1 and U2 uniform variables U1 and U2 in order for the formula to work.